Hey guys, Mr. Backerberg here. In this video, we're going to look at separable differential equations. So, a differential equation of the form dy dx equals f of y times g of x is called separable because we can separate the variables. We can get all the things that have y variables in them on one side and all the things that have x variables in them on the other side. So we can rewrite it in the form 1 over f of y dy equals g of x dx. So we can think about it like algebraically manipulating this differential equation. Think about it as multiplying the dx over to the right-hand side and dividing the f of y over to the left-hand side. And then once we separate the variables, then we can find the solution by anti-differentiating or integrating each side with respect to its isolated variable. So integrating with respect to y on the left-hand side and with respect to x on the right-hand side. So in this example, we're going to solve this differential equation by separating the variables. So we're going to solve for y if we know that dy dx is equal to x times y squared, and we know that y is equal to 1 when x is equal to 1. So the first thing we need to do is rewrite this so it looks like an x times a y. So having this xy squared, we can really rewrite this as dy dx equals x squared times y squared, just squaring each one of those variables. And now what we're going to do is separate out the variables. So I'm going to multiply this dx over to the right-hand side, and I'm going to divide this y squared over to the left-hand side. So we can write this as 1 over y squared dy, and that's going to equal x squared dx. Now I'm going to make one adjustment before we do the integrating. I don't like having this fraction in here, so I'm going to rewrite this 1 over y squared as y to the negative second power, and then we'll leave everything else the same. And now what we're going to do is integrate both sides. So if we start with that y to the negative second power on the left-hand side, we're going to use our anti-power rule. So we add 1 to the power. If we add 1 to negative 2, then we get negative 1. But then we're going to divide by that new power. And then same thing on the right-hand side. It's going to be anti-power rule there. So take that x, add 1 to the power, but then divide by that new power. Now these are technically indefinite integrals, so we do need to put the plus c. We don't need to put it on both sides, though. We only need to put it on one of the sides. Now to solve this, we need to figure out what that c value is. So we were given an initial condition. We were told that y was equal to 1 when x is equal to 1. Or we could think about that as the ordered pair 1, 1. So we're going to take that information and we're going to plug that in for our x and for our y. So then this will say 1 to the negative first power over negative 1 is equal to 1 cubed over 3 plus c. Now we're solving to get c alone. 1 to the negative first power is still 1, and then 1 divided by negative 1 is negative 1. 1 cubed is 1, divided by 3 is 1/3. So we've got negative 1 equals 1/3 plus c. We want to get c alone, so I'm going to subtract this 1/3 over to the left-hand side. Now I'm going to get common denominators over here when I do this. So negative 1 is really like negative 3 over 3. And if we subtract another 1/3 from that, then we're going to get negative 4/3 as our c value. So now we can take that c value and plug it into our equation right here. Now I'm going to clean up the left-hand side just a little bit. Having y to the negative first power divided by negative 1, that's really going to be negative y to the negative first power. Then we've got the x cubed over 3, and then we just solved for our c value, so that's negative 4/3. Now we are going to solve this to get y all by itself, but first on the right-hand side, I notice that those fractions have common denominators, so I'm going to go ahead and put them together right away. So this is going to be x cubed minus 4 all over 3, and that's still equal to our negative y to the negative first power. Now to get rid of that negative in front of the y, I'm going to divide by negative 1, and when I do that on the right-hand side, that's really just going to change the signs on the numerator, so that x cubed is going to become a negative x cubed, and the minus 4 will become a plus 4, but everything else is going to stay the same, and then on the left-hand side, that'll just turn into a y to the negative first power. Now we don't like to have negative powers in our answers. So remember, y to the negative first power is really the same as 1 over y, and then we've got that equal to the negative x cubed plus 4 over 3. Now, we don't want to have that 1 over y on the left-hand side. We want y to just be a regular y. So what we can actually do is the reciprocal of the left-hand side. We can flip that over to make it just say y equals. But if we flip the left-hand side over, then we also have to flip the right-hand side over as well. So we get the equation y equals 3 over negative x cubed plus 4. That's going to be it for this video. Thanks for watching.